All right, today's topic is about the Pythagorean Theorem, okay? So we're still working with triangles, we're still doing geometry, and this one has a specific formula that we all know. We've learned this in the past, and now we're going to do it again, okay? So remember, when dealing with this formula, you have a triangle, okay? And then it's a right triangle, okay? Now, when you label this side will be A, this side will be B, and this side will be C. Now, your A and B, it doesn't matter which one. It doesn't matter which one you use for that side. What really matters is C. Okay, the C is always across from your right angle box. Okay, so whatever diagonal or line you have across from your box, that's your C. Okay, so the formula, if you remember, is A squared plus B squared equals C squared, okay? So basically, if you take this side and you square it, and then you add, you take this side and you square it, and you add those together, it should get this side squared, okay? So for example, if we took these away, okay? Actually, let's do the whole thing. Let's do an example here, okay? I'm gonna leave this up here of A, B, and C, all right, with my A squared plus B squared equals C squared, okay? So if I leave that here, let's do an example, okay? So if this side is 3 and this side is 4, what's this side gonna be, okay? And that's what we're gonna try to figure out, okay? So when we have this, we plug it into our formula here and just see what it is, okay? So first step is our A is 3. So we're going to do 3, and that's going to be squared, okay? So 3 squared. Our B is 4. So it's going to be plus 4 squared, and that equals C squared. We don't know what C is. That's what we're trying to find, is our C squared, okay? Now, we just do the math, okay? So 3 squared, okay? So remember, if you have a calculator, 3 squared equals 9, okay? Plus 4 squared, okay? So 4 squared equals 16, so plus, and that equals C squared, okay? Now, add your numbers up. 9 plus 16 equals 25, and that brings down your C squared. Now we have our last step here. 25 equals C squared. So we need to figure out what C is by itself, okay? What C is, okay? We have C squared. So your last step, to get rid of a square, your last step is to square root your number. So if we take 25 and we square root it, our answer is 5. So C equals 5, and that's what would go here. Okay, and which makes sense, right? Because 9 plus 16 equals 25, and that's what we want, okay? So let's do another one. So let's do 9, 12, and 15. Oops. Well, okay, that's fine. So, actually, no. Sorry, wrong one. Let's do 6 here, 8 here, and we define our C, okay? So, same thing. Plug in our formula. So 6 squared plus, and B squared, which is 8. 8 squared equals C squared, okay? So do the math. 6 squared equals 36. 8 squared equals 64, okay? Now we add those together. 36 plus 64, 100. So we have 100 equals C squared. And our last step, remember, is to square root our number. So square root of 100 is 10. So C equals 10. Okay? Easy as that. Now, what if they give you another, what if they give you C and you're trying to find another letter? Let's try that. Okay, so let's give you 12 here and 13 here, but here is what you're trying to find. So we need to find our B. We have A, we have C, we need to find B. So now we're going to plug it in there. We're still going to plug it into our formula here. Our A squared, so 12 squared, plus, and we don't have B, so we need to find B squared. That's what we need to find. And then our C squared is 13. Now, do what we know. 12 squared, okay? Remember 12 squared, 144. So 144. B squared, we don't know. We bring it down. 13 squared, 169. Okay? Now, we have this problem here. So what do we need to do to get this letter by itself? Well, we need to move this 144 to this side. 144 is positive. What do we do with it? Opposite, subtract 144 here and 144 there. That cancels. Bring down our B squared, and 169 minus 144 equals 25. So now our last step is the square root. And the square root of 25, we know, is 5. So B equals 5. Okay? So it's just working backwards, okay? So instead of adding them, you're going to subtract them in square root, okay? Let's do one from the book, and I'll put that up in a sec. So here's number 1 of our first assignment, okay? So it says, new cell phone towers are being constructed on a daily basis throughout this country. Typically, they consist of a tall, thin tower supported by several guy wires. Assume the ground is level in the following. Round answers to the nearest foot. Okay. So A says the guy wire is attached on the ground at a distance of 100 feet from the base of the tower. The guy wire is also attached to the phone tower 300 feet above the ground. What is the length of the guy wire? Okay. So what do we know? Well, we know that attached on the ground at a distance of 100 feet from the base. So our base here is 100. So if we draw this out, okay, our ground here is 100, okay? And then it says the guy wire is also attached to the phone tower 300 feet above the ground. So it's attached 300 feet above the ground. So our side here is 300. What is the length of the guy wire? Here's our guy wire. What is this length here? That's what we're trying to find. Now we know it's C because it's opposite of our little box. Our little box here is opposite. That's our C. That's what we're trying to find. So let's go ahead and solve this. Okay. So set it up. A 300 squared plus B, which is 100 squared, equals C squared. Let's do the math. 300 squared, 90,000, plus 100 squared, 10,000, equals C squared. Add these two up, 100,000 equals C squared. Last step, square root. We square root that, and we get that. You get a decimal, go ahead and round. 316.2 equals C. And it's easy as that.